In the simple smart home system we designed, when the concentration of combustible gases in the kitchen surpasses the acceptable limit, the exhaust fan must be turned on to promptly expel the gases to the outdoors and reduce their concentration. Therefore, our lesson today is designing a simulated exhaust fan circuit. Through this lesson, we will understand the components of a simulated exhaust fan circuit and be able to select the appropriate components based on actual needs. The key point of this lesson is the composition of a simulated exhaust fan circuit. The difficulty lies in selecting the right types of components. In this lesson, we will design an exhaust fan circuit that can realize two control modes, manual control and the microcontroller's automatic control. The simulated exhaust fan circuit consists of two main parts, the transistor relay driver circuit and the load circuit. The transistor relay driver circuit uses the switching function of the transistor to control the relay's on or off state. The load circuit is to operate the exhaust fan as an actuator when combustible gases exceed the limit and to display the operating status of the exhaust fan using an indicator light. After determining the composition of the system, we also need to determine the way to achieve the circuit function. In the transistor relay driver circuit, the microcontroller 51's I/O terminals typically exhibit a stronger low-level output capability compared to its high-level output. Additionally, to prevent accidental relay activation upon power-up, adopting a low-level drive design that employs negative logic proves to be a more advantageous approach. Therefore, this project uses a PNP transistor relay driver circuit. It should be noted that the sudden cutoff of the transistor can lead to the generation of a self-induced electromotive force within the relay coil, posing a risk of damaging the transistor. To mitigate this risk, a diode should be connected in parallel with the relay coil, creating a path that dissipates the self-induced electromotive force and thereby safeguarding the transistor. The load circuit consists of a small exhaust fan and an exhausting indicator light operating in parallel. To prevent the exhausting indicator light from being damaged by excessive current, a current-limiting resistor is typically connected in series before the indicator light. The operating principle of the simulated exhaust fan circuit is as follows. When the button is pressed or the microcontroller outputs an action signal, the transistor conducts, energizing the relay coil, and the relay's NO contacts close, turning on the exhaust fan and illuminating the indicator light. When the button is released or the microcontroller's action signal disappears, the transistor stops conducting, de-energizing the relay coil, and the relay's NO contacts return to their original state, causing the exhaust fan to stop and the indicator light to turn off. Now, we have determined the basic framework of the simulated exhaust fan circuit. Having determined the basic framework of the circuit, it is also necessary to select the correct components to complete the design of the circuit. The operating current of the exhaust fan during startup and normal operation can reach 100 to 300 milliamperes, so a 5 volts relay is required to drive it. Besides, according to the relay's data book, the relay operates with a drive current of approximately 70 to 100 milliamperes when functioning normally, and the relay is activated under low-level input voltage conditions. Therefore, we use the PNP low-power transistor 8550, which has a maximum collector current of 500 milliamperes, to drive the relay coil. Now, we have finished designing the simulated exhaust fan circuit. Through this lesson, we have learned that the simulated exhaust fan circuit consists of two parts: the control circuit and the exhaust fan circuit, and components such as transistor 8550, intermediate relay, and small fan are selected as required. That's the end of this lesson. Thank you for watching.